Welcome to qnawire.
Were fired upwards, and they reached the same height at the same moment, although the first arrow had been fired earlier. And we have to determine the initial velocity of the second arrow, knowing the initial velocity of the first arrow. Let's first draw the situation. So initially, the first arrow was fired up, but the second arrow was stable. And it occurred at the moment of t equals to 0. And here we'll introduce the time axis t1, which is related to the first arrow. Then, after some time, at the moment t1 equals to delta t, the second arrow was fired. So the first arrow was still moving, and the first arrow was fired with its initial velocity v2 0. Then, later, at some final moment, which is here is t1 equals to t final, they both reached maximum heights. And the fact that they reached maximum heights means that each velocity was 0. So now let's write down the equation for both velocities. So for the first arrow, velocity equals to initial velocity minus gt1, and for the second velocity, for the second arrow, its velocity is v2 0 minus gt2, and t2 equals to t1 minus delta t, because the second arrow was fired up later. So when h is maximum, both velocities are 0. So therefore the equation becomes v1 0 equals to gt1 and v2 0 equals to gt2. And again, t2 equals to t1 minus delta t. So now we can simplify this expression. From the first equation, t1 equals to v1 0 over g. So therefore, second equation becomes v2 0 equals to g v1 0 over g minus delta t. Or we can further simplify it. It becomes v1 0 minus g delta t. So let's complete this calculation. It's going to be 25.0 meters per second minus 1.20 seconds multiplied by 9.81 meters per second square. So now I'm going to use a calculator to have it done. So it equals to 13.2 meters per second. Here is the solution of this problem. I hope I helped you. Thank you very much for visiting. Bye.